Welcome to Let's Make a Game, a platformer, episode 6. In last episode we added capability of rendering characters. As an example, at the moment we have only one character, which is the player. And this is the stone block rendered here. The character rendering renders the character based on the location component and its values for X, Y, and Z. So at the moment, this is all we do, we just render it. So maybe let's start with making it possible for the character to actually move. So, but first we need to make our context aware of a passing time. To do that, we will add a time profile, which will activate this small time manager. And also we will have to long last update time. We'll have to notify the time manager that how much time has passed. Why we didn't do it automatically in the time manager, I'll show later on. But for the time being, let's just go with this. So when we start the application, we'll start the clock, saying this is the last update time. And the time passed since last frame. Time passed is current time minus last update time. And last update time will be incremented by time passed. And then finally we will use the internal time manager to update by the time passed between frames. Okay, so let's run it, and this will crash. Why it will crash, I will show in a moment. So it will be visible in the error here. We need to give the manager something an entity where it will store the time. So we will create here a package logic, because it's going to contain all the game logic. And let's say here platformer time entity provider. We have to register it and make sure that we share the time entity provider so that the time manager can actually see this. And then we implement a method. So let's also make it lifecycle system so that we can use entity manager to create a new entity where we will be storing the time in. So let's go with this. In initialize we will do this is the entity, time entity equals entity manager create entity, and we will return it here, time entity. Excellent. That's all we have to do, I hope. Let's see if it crashes or if it passes correctly. This has no visual impact at the moment on the game itself, but now our context is aware of time, of passing time. So let's now do some controls. So in the logic we'll have controls. And let's add the component which is going to be called player controlled component. It's going to be an interface. So it has to extend a component, as every component in my ECS has to. And so this is more of it doesn't store any data, it's just more of like a flag component saying, oh, by the way, this entity, whenever player does anything to the character, so presses arrow keys or whatever, this is the entity that should be updated. And there can be multiple of them. So imagine you have a player controlling multiple characters at the same time on the screen, and all of them might have the same component, player controlled component. And it's an empty component. And now let's create a keyboard system. So we'll be steering our character with a keyboard. We'll register it, of course. And here is the fun part. So on a PC, so on a Windows or Mac or Linux, you will have keyboard. However, if you will have this game running on your phone, there is no keyboard, at least not keyboard in the sense of having arrows, LWSD, or any other kind of steering like that. So what you might want to do here is just say that this is going to be activated only if keyboard profile is present. And instead, now adding this to our game, the profile to activate keyboards, we will instead have here additional profiles. So we'll pass it in a, maybe not set here, collection. So the profile to activate specific for a platform will be passing in a constructor. So in here we'll do activate profiles, add all additional profile, no, not active, additional profiles, and we will pass this in the launcher. We'll pass here, for the time being, we'll just say keyboard is the profile we want to activate. So this should be active now. So what we'll do here, first of all, we want to attach ourselves to, sorry, not just inject. You want to talk to the game loop. And we want to, in the initialize method, we want to game loop. Let's import it quickly. Game loop, add game loop listener this. So we want to be notified by the game loop on each update of the frame, before the frame is actually updated. And so this is the method that's going to be called. So in here we'll be doing a couple of things. Let's for now just do left and right keyboard manipulation, the character manipulation. So let's go with private, I think it's called input key, the class, I don't remember, GDX input get is key pressed, and it's keys, yes, okay, keys. So input keys, let's quickly, it's an integer, so it's an array of integers. So left keys will be steering with input. So we'll add support for both left arrow as well as A key. Okay. Right keys, input keys right, or alternatively a D can be used to steer to the right. So in here we'll do left pressed is left pressed. We'll add those methods in a second. Right pressed is right pressed. So let's add them. So we'll iterate through left keys, and if GDX input is key pressed left key, return true, otherwise return false. We can make this even more interesting by making it a parameter. Oh, let's make it, sorry, parameters. Let's call it keys. Make this one a key, and is any pressed, and make to is left pressed, which will do return is any pressed left keys, and do private boolean is right pressed is any pressed right keys. Okay, so we now know. So let's now do is if left pressed and right is not pressed, else if right pressed and not left pressed. So if you press both right and left key, we will not do anything. We will do only if either one of or the other is pressed, either to the left or to the right. So what we need to do here is, first of all, let's inject the time manager, and in time manager from time manager we'll get time since last update. Excellent. So what we'll do here is, so this is in milliseconds since last update. So we will first of all, I previously already used entity index manager because we'll be iterate. So what we want to do is iterate through all the entities that have the player controlled component and modify their position. So this is going to be done on every frame. Therefore, we need to make sure that we use an index for iterating through those components. And what we are interested in is in a player controlled component and location component. So so this index will give us access to controlled entities. Will give us access to all the entities that have both player controlled component and have the location component, because that's what we're going to be modifying, location, and for those that player is controlling. So we'll iterate here. So let's go with if it's left pressed, then xdiff will be minus time since last update times 1 divided by 1000. So we will be moving 1 block per second, maybe more, maybe 2 blocks per second. Xdiff time since last update times 2f minus divided by 1000. Let's extract this as a blocks per second. It's blocks per milliseconds. So left will decrement the x, right we will increment the x, and here if xdiff is not 0, we will iterate through all controlled entities. Not through entities, but through the entities we actually get from there, and we will extract the location component. Location set x, location get x plus xdiff, so the difference. And now we just have to remember to save changes to the entity, otherwise they will not be available. So I think that's it. Let's see how it works, and if it works. Yeah, I'm pressing left and right, A and D, Awesome. Well, now we are seeing the problem. Our camera is not moving with our character. This is something that we can fix now that we have the keyboard manipulation. Maybe I'll just speed it up a bit because it was a bit slow. Let's try 4 blocks per second. How it looks. Oh yeah, that looks better. Okay, so what we have to do now is we are interested in making sure that the camera is following the character. So the way we did the camera at the moment is in this class, where we just always set it at 0, 0 and distance from terrain, which is 8 blocks away from the terrain. So what we want to do now is modify this class to make sure that it follows our character. But to be honest, we don't want to follow a character, because imagine you'll have a 2-player game where the players play on the same screen using the same keyboard. One of them uses the WASD or arrow keys, or they play over the internet or local network. You want to be able to have camera follow multiple objects possibly. So how we achieve that is we'll add a new component here, maybe add it here in the rendering, which is going to be camera focus component, and has to be an interface, and of course has to extend component, because that's how I designed it. And so now imagine, so every object that's in the game that wants to be visible at the same time, let's just go for this time being to make it simple, has to have this component, and the camera will try to accommodate to make all the entities with this component visible on the screen. However, imagine, for example, another scenario where we don't have 2 players is that player is playing a bit of platformer, moving forward, and suddenly encounters a boss fight. In a boss fight, you don't really want the camera to be focused on the player. You want the camera to be focused on the battleground. So ideally you would like to have like player on one side of the screen and the boss on the other side of the screen. However, the problem with this is that when your character moves and approaches the boss, the camera will suddenly switch from focusing, so having the player character in the middle of the screen, to suddenly it will blink to having 2 characters, the boss and the player on the screen. This is not very good. How we can fix it is that we can have the boss character always have the camera focus component. However, what we can do here is have a float get focus weight void set focus weight. So we can say that at the beginning, when the game starts, the boss is there somewhere far away. However, the focus for the weight, how important this character is 0. So this is not important, don't even bother looking at it. Whereas the player character will have a focus of 1, which is this is the important thing that we want to focus on the camera. However, if the player approaches the boss close enough, be it, I don't know, distance of 20 blocks or something, will suddenly slowly increase the weight of the boss character to reach 1 as well. That way, when it's gonna reach 1, then the importance of both player character and the boss character will be the same. So we'll achieve the having 1 character on one side of the screen, another character on the other side of the screen. So that's how we do this. That's what the focus weight means. So let's now add this component, which is camera focus component, to our player. And as I said, value of 1. Okay, so we have value of 1 for our player, and our rendering here. So once again, this is gonna be done once per every frame. Therefore, we need to make sure we use an index for iterating through all entities that have this component. So entity index manager, and in initialize we will add index on components. We are interested in camera focus component and location component. We want to be able to concentrate on those entities. Camera focused entities. Okay, so we'll be iterating through all of them. Camera focus entities, get entities. We'll be summing out the weight. And X, Y, sorry, not Y, Y. 0. Okay, so let's do entity ref, get component, location components. It's very similar to what we had before. Location. And we also want to get entity ref, get component, camera focus component. Camera focus, float weight, camera focus, get focus weight, and maybe only if weight greater than 0, we'll do the rest part because we don't need to do it if it's not 0. X plus equals location get X, Y plus equals location get Y, and weight sum plus equals weight, and then we have to normalize it for the weights. Result X equals X divided by weight sum, float result Y, Y divided by weight sum, and X, result X, result Y, and look at also result X, result Y, and the up doesn't change, up direction. Okay, so let's quickly explain this. So we are going through all the entities that have this camera focus component and location component. We check the weight of the entity, and if the weight is greater than 0, so it has any meaning, any importance, we'll get the location and add it to our sum of, let's just call it sum X and sum Y. So we add these together and also make sure that to increment the weight. So let's say we have two characters or two objects, entities in the scene that have both weight of 1. We will get X of both of them, sum it up, and divide it by 2. So basically an average. So we'll be in the middle. The focus of the camera will be exactly in the middle in the X coordinates for those two characters. And the same for Y coordinates. That way we'll have a camera always in the middle of the two characters. However, if weight of one of them is going to be only half, then that doesn't make sense. Well, let's go with this. I'll fix it later. Yeah, we have to here multiply it by weight, I believe. I believe so. Yes, I think that's how it's supposed to be. Anyway, if not, I will fix it. So let's try to run this quickly. So this is what we did. We just wrote, 20 lines of code, and now our camera should be able to not only follow the player, but also possibly focus on multiple things that we have on the screen. So that's working, and awesome. However, so let's try it quickly once again. I'll show another problem. Let's imagine we have this level that so let's say that this is our left boundary of our level. So whenever we character moves to the left here, we don't want the whole things moved, the terrain moved to the right. So what we can do is add quickly a new component. It's going to be an interface, camera bounce component, extends component. Of course, this is very important. Can't forget that. And let's define here 4 floats. Minimum x, maximum x, minimum y, maximum y. And since these will be something that is associated with a level, we will add these to level prefabs. So we'll have camera bounds, because as you can imagine, every level will have a different maximum bounds of the terrain. So we will say here that min x is 0, min y is 0, max x is 10, min max y is, let's go for 10 for the time being. This is just something that you'll be doing yourself whenever you'll be designing the levels. You have to figure out what kind of bounds you want to have the camera. And now let's quickly make it possible for the camera to work with it. So entity index, once again, camera bounds, entities, and we want to be able to camera bounds entities, entity index manager, add index on camera bounds component. And so in here we'll do we'll iterate through all the entities that have camera bounds. Well, not all entities, we will just get the first one. Bounds entity, get component camera bounds, and finally, camera bounds. And finally, we want to result x to be a minimum of result x, and camera bounds get max x and a maximum of, I don't know if math has a class for clamping, method for clamping. No, it doesn't. Okay, so max of this, and camera bounds get min x, and the same for y. So basically we are making sure that it's these values, result x and result y, will always be within minimum and maximum. So let's try, run it. And see how it works. So whenever I move to the left now, the screen should not move. Oh, it does a bit, yeah, but not much further than this, yes. And 10 blocks away. Awesome. That's exactly what we wanted to achieve. Great. So the reason why it allowed me to move to the left is because the starting position of the player was 2 on the XY axis. So let's go for 0, so that now when I start it and I move to the left, it will not move the screen, not move the camera. Yes, okay. Excellent. That is superb, exactly what you want to achieve. So now we have, first of all, added a keyboard control to the character, the player character in this case. We allowed the keyboard to steer more than one characters or none. So you can, for example, at some point in time, you can remove the player controlled component from the player entity, and then keyboards will no longer work for the player. And then you can re-add it at some further point. For example, when some other character takes mind control of the player, you can remove it and then re-add it at some later point, and so on. So what we did is this. Then we allowed the camera to follow the player, also follow more than one characters on the same screen, and get the proper camera placement to show all of those characters. And also what we added is that level can have bounds for the camera, so you won't be able to move outside of those bounds, because you, for example, might not have anything drawn there. You might be out of backgrounds, graphics anymore, and so on. So as you can see, adding control of to the player was like, I don't know how many lines, it's like 20 lines of actual code. The camera setup is another, 15 lines. It's all pretty easy and I hope straightforward. Okay, so that's it for today, for this episode. Thanks for watching, and I hope you'll see the next ones. Bye!